where there's a keypad, right here where it says speed limit 10 miles, they're going to come open that gate for us.
Just on the opposite side of the lake. This is somewhere.
This is the Cotton Cove Compressor Station.
I know exactly what you mean. You mean you.
There you go. Make sure that we're fire resistant at least for the combat fire. Oh, yes, I am. You're all welcome.
Coming back and
You actually interviewed me in Bridgeport.
yeah.
It's been a while. It's been a minute.
And
Telling her about
carbon sequestration capture stuff.
Yeah.
yeah. Yeah.
Pretty large horsepower units. And all we're trying to do is we gather gas from the well in the field, we boost it up to pressure, and then we send it to this facility to get basically processed. We strip out the CO2 and we dry the gas before we offload it to a long haul site. If you look, these are our 22 TRWD, and then we'll have the boosting right here from all the wells that are local right here in Cotton Cove. Will come through this compressor, and then we actually go through the filters before we send it up to the facility. That's a 24-inch jig. They're pretty massive. It's used to sweep through the pipeline system, clear out water, bacteria, things like that.
About 1,000 pounds. Cotton Cove is actually coming in right here and mixing in with Saginaw and TRWD right here. And so on this side of it, we're at high pressure. We start at 1,000 pounds right here. So
The larger,
that's, yeah, that, and it's actually a scrubber. It's our inlet scrubber for the facility.
Yeah, it's an additional water knockout vessel, basically.
The process side is designed.
So what an amine tower does is it's filled with amine, which is a chemical, and all we do is we send gas through the bottom of it, and it bubbles through that fluid. And as it's bubbling through that fluid, we get the pressure going.
Okay.
As you can notice, the pressure drop causes ice.
Yep.
So, if you're ever curious kind of how a fridge works?
Yeah. Yeah, cutting it down, squeezing it.
On the gas well side, because a lot of the reservoir fluid that you're bringing up is at 180 degrees, 190 degrees, so by the time it reaches the surface, you have warm water, but when you're dealing with gas, every time you have a pressure drop, things like that, you go over and feel it gets cold, and you cut down to just the pressure thing that's causing that. Back over here on the right.
Yeah.
So how many plants like this does it take?
Yeah, there's a big one in Bridgeport. I think there's like 4 or 5 total. Some we own and some are owned by the midstream company. Okay. The one in Bridgeport.
CO2, but we're using
So part of the reason why you have to put it to a flash freeze
process the best way to keep it efficiently, water coming out.
It's a flapper check, and it'll sit there and bounce. When you first get in the industry, stuff like that makes you real nervous. this is where the CO2 actually comes into the capture facility. I'll go right over here. Oh, it's right here. Sorry, wrong one. See, I got confused. This one right here. It'll actually go to another vessel. So this is for water knockout. The main reason this one's here is we cannot send any water to that blower. If you send water to that blower, bad things going to happen. So this is just an additional.
So this is carbon capture because it's turquoise, and they're injecting the carbon dioxide back into the reservoir.
That is the new technology out of Canada. I have no idea how it works.
So basically, what we're doing with that is essentially like the solid gas and JT vector. We use pressure run through a JT valve, and that we drop out the liquid. And once again, we're trying to find out moisture. We want to take out as much moisture as we can, especially out of CO2. Something acid. It's an H2S.
Cool. Yeah. So from compression over to the well, is that all chrome here?
So once you dehydrate, and it's not corrosive. So CO2 is corrosive because of the interaction with water, carbonic acid. So once you remove the water, it's carbon steel. It's all pipelines, all CO2 pipelines. Denbury or Exxon now has that one from Jackson, Mississippi to Houston, and it's all carbon steel. We've been operating it for lots of years. So yeah, dehydrated CO2.
So this is 11 wells, XTO wells in the Barnett, and we're going to go take a look at them. And this is called the pad of the future.
These are the valves I'm talking about that are now driven by air here. We call them Kim rays, or people call them motor valves. All the same. It's like any lingo. We call it kick rays. That's just simply a brand. So air opens the device. Whenever we have a little 12-volt signal, sit to this ASCO valve. It's just a valve that simply switches, allows air by it, and then closes when we're ready to shut in the well. So it'll exhaust, and it just closes, but it's exhausting clean air instead of natural gas.
So all these wellheads here.
How long did it take you to change out the pneumatics? How long did it take us to change it? I mean, once they plugged in the blue airline, you can see it. This is like a plastic with a small steel casing on the inside. We had a crew come out here on a bigger pad like this. Might be a 2-day job. Smaller pads, they're in and out in a day, and we're running on air. Had a big project a few years ago that kicked off called Air Jordan, you know, and so they started going around changing everything over to air. What's your wellhead pressure here? Right now, if I can see that, these gauges aren't as reliable. This is showing about 100 pounds. Come back up here. See digital gauges reading.
Each one of these is a wellhead, and there's 11 of them, and they're connected to horizontal wells in the Barnett Shale. So quite a lot of production is coming up through these pipes.
We have 3s, 4s, 5s, depending on how much water makes in the well, and gas will upsize the holes in it so it can fall through it. This particular plunger, if that well was doing 800 MCF and 80 barrels a day, this one wouldn't fall through that, right? So you get more holes, so you can fall through more flow. It goes down all the way to our bumper spring, generally set at about 45 degrees, and our tubing string, somewhere around 7,000 foot, 6,500 foot, depending on each individual well and where it's at. When it sets down on that bumper spring, it sets down on a fishing net. I don't have a bumper spring. This is another style of plunger. But basically, what this is sitting down hole, boom, and so now it's a solid piece. Once it becomes a solid piece, the flow of the well brings it right back. So we're just sweeping fluids out of the tube. This we call a conventional plunger. It does the exact same thing as this, except this is not designed to fall through flow, so it has a longer drop time. So we'll shut it in for 35 to 40 minutes to get this on the bottom. Then we'll open the well and bring it up back.
So here we're at Barnett. And there's 11 wells on this pad, and they're all horizontal. So some of the wells are going this way, and some of the wells are going this way. And it's a really good use of the surface area. So on a few acres, they can have all these different wells, as opposed to making a separate pad for every well.
And these are the produced water tanks.
So these are, we think about 400 barrels per tank. Our guide is not 100% sure, but that's kind of interesting, because if that's the case, these 3 tanks would be 1,200 barrels. And there are some wells, not maybe here, that produce 1,200 barrels of oil a day. So that'd be quite a heck of a lot of oil.
Well, it's water though.
This is water,
And this is separate tank.
but that's the tanks that would hold it.
Wow.
We have pads called CCUS. And whenever this thing needs a little supply, it opens up, lets it in. High pressure gas comes in here, and this is like a two-way valve, so to speak. There's a piston on top and a piston on bottom. So it just sits there like a bicycle pump, right? Pulls air in here, and as this high pressure valve, this switches and strokes this back and forth, it exhausts it here. All this went into outside line, and it ties back into something, right? So we're using gas, right, to stroke the pump just as it works to create air pressure. We hold about 55 pounds of air pressure on this thing, between 50 and 55. You can hear it going now. There you go. So we're at 56. So we got a low side of 52 and a high side of 55. We're at 56. So as all these different pneumatic devices start opening, closing, dumping fluid or whatever, this thing will keep pumping itself up and keep them supplied with air.